What if Yellowstone supervolcano decided to wake up tomorrow? Welcome to our deep dive into Yellowstone National Park, a breathtaking natural wonder, and home to one of the world's most formidable supervolcanoes. Today, we'll explore the beauty above and the power lurking below, uncovering the mysteries of this geological giant. Is there any real threat of an eruption? Let's find out. Yellowstone National Park, located in Wyoming, is not just America's oldest national park but also a geological marvel. For a mere $35 entry fee, visitors can explore its vast expanse of 2.2 million acres, showcasing breathtaking mountains, iconic geysers like Old Faithful, and a diverse array of wildlife including bears, wolves, and bison. The park's meticulously preserved landscapes make it a haven for nature enthusiasts, offering everything from panoramic hiking trails to vibrant hot springs. But beneath this picturesque landscape lies something far more formidable, a supervolcano. This geological giant is responsible for the park's famous hot springs and geysers, but it also holds the potential for cataclysmic eruptions. A supervolcano is not just a larger version of a typical volcano, it's a colossal force of nature. To be classified as a supervolcano, it must have had at least one eruption expelling over 1,000 cubic kilometers of material. For perspective, the 1980 eruption of Mount St. Helens released less than 3 cubic kilometers. Yellowstone's most significant eruption occurred around 2.1 million years ago, releasing about 2,450 cubic kilometers of material. This event, among others, has shaped the park's unique geology. The Yellowstone caldera, the volcanic crater beneath the park, has experienced 3 major eruptions, the last occurring approximately 640,000 years ago. Since then, numerous smaller volcanic events have indicated ongoing geological activity. Think of a supervolcano as a massive pressure cooker. Magma from deep within the Earth's mantle rises towards the surface but is held back by the crust. As pressure builds, the ground begins to bulge, signaling an impending eruption. When the pressure finally releases, the eruption is explosive, ejecting enormous amounts of lava, ash, and debris. Yellowstone has experienced at least 4 major volcanic caldera events, each leaving behind massive underground chambers filled with molten rock that gradually refill over time. The impact of a supervolcano eruption extends far beyond the immediate blast. Ash can spread globally, creating a thick layer that darkens the skies and blocks sunlight, potentially triggering a volcanic winter. This phenomenon can lead to drastic drops in temperature, affecting global climate, agriculture, and ecosystems, posing a significant threat to all life forms. Despite the low probability of an imminent eruption, scientists and experts continue to study Yellowstone closely. If the supervolcano were to erupt, it would unleash energy equivalent to 1,000 Hiroshima bombs in a single second, causing massive earthquakes and shock waves. The destruction would be widespread, impacting cities like Jackson, Bozeman, Billings, and Idaho Falls. The shockwave could claim nearly 1 million lives and trigger pyroclastic flows, dense clouds of ash and gas that travel at high speeds and devastate large areas. A 2014 study by scientists Larry Maston, Alexa Van Eaton, and Jacob Lowenstern detailed the catastrophic aftermath of a Yellowstone eruption. Vast areas of the United States would be buried under layers of ash, disrupting life as we know it. The ash plume would reach the stratosphere, encircling the planet and blocking sunlight, leading to a global cooling effect and threatening food production and ecosystems. However, the likelihood of such an event happening soon is minimal. While Yellowstone experiences frequent earthquakes and ground swelling, these are not definitive signs of an imminent eruption. Scientists closely monitor these activities and use advanced technology to predict potential eruptions. They are confident that there would be clear warnings before any major volcanic event, giving people time to prepare. Despite the sensational headlines and public concerns, Yellowstone is not on the verge of erupting. Recent studies have shown that while the magma chamber beneath Yellowstone is large, the amount of melted magma is relatively low. The caldera consists of porous rock layers, not a vast pool of molten rock waiting to explode. Predicting volcanic eruptions is complex and cannot be based solely on past intervals. While the average interval between Yellowstone's major eruptions is roughly 730,000 years, this doesn't mean an eruption is overdue. Volcanoes don't follow a regular timetable, and the magma in Yellowstone's caldera doesn't accumulate at a steady pace. In reality, while the Yellowstone supervolcano garners attention for its cataclysmic potential, the likelihood of such a massive eruption is relatively low in the near future. Instead, smaller volcanic activities such as hydrothermal eruptions involving steam and hot water are more common occurrences. These events, while significant locally, pose less of a global risk compared to a supervolcanic eruption. Yellowstone National Park is renowned for its geothermal features, including geysers, hot springs, and mud pots. These geothermal features offer valuable insights into the park's volcanic behavior and serve as indicators of the underlying volcanic activity. Hydrothermal eruptions, which involve the release of steam and hot water from underground reservoirs, occur sporadically and are part of the park's dynamic geological processes. While hydrothermal eruptions can cause localized damage and pose risks to visitors if they are in close proximity, they are manageable events that do not typically result in widespread devastation. The park's monitoring systems and scientific research help to track and understand these phenomena, enhancing safety measures for visitors and park staff. The ongoing study of Yellowstone's geothermal features is a cornerstone of volcanic research, offering invaluable data that helps scientists understand the complex dynamics of volcanic activity and assess potential hazards. The park's geothermal phenomena, including geysers, hot springs, fumaroles, and mud pots, are not just tourist attractions but also critical indicators of the underlying magmatic and hydrothermal systems. By meticulously monitoring these features, researchers can detect subtle changes in temperature, gas emissions, and ground deformation, which provide clues about the movement and behavior of magma beneath the surface. Advanced monitoring techniques, such as satellite imagery, seismic sensors, and ground-based measurements, allow scientists to track these changes with remarkable precision. For example, variations in geyser activity or shifts in the composition of emitted gases can signal alterations in the magma chamber's pressure or the migration of volcanic fluids. These observations help build comprehensive models of Yellowstone's volcanic system, enhancing our ability to predict future events and develop effective response strategies. Understanding geothermal activity is crucial for preparing for potential eruptions, however unlikely they may be in the near future. While the Yellowstone supervolcano's catastrophic potential often garners sensational headlines, scientific assessments indicate that the probability of such an eruption occurring within our lifetime is exceedingly low. Continuous monitoring ensures that any significant signs of volcanic unrest are detected well in advance, allowing for timely warnings and mitigative actions to protect public safety. In the meantime, Yellowstone National Park remains a spectacular natural wonder, drawing millions of visitors annually. It serves as a living laboratory where the forces of nature are on full display, from the dramatic eruptions of Old Faithful to the vibrant hues of the Grand Prismatic Spring. The park's dynamic landscape offers a unique opportunity to witness the interplay between geological processes and the environment, reminding us of the powerful forces that have shaped, and continue to shape, our planet. As scientists delve deeper into the mysteries of Yellowstone, they not only safeguard against potential volcanic hazards but also enrich our appreciation of this extraordinary natural treasure. Thank you for joining us on this journey into the heart of Yellowstone National Park. If you enjoyed this video, make sure to like, subscribe, and hit the notification bell for more fascinating explorations of our world's most intriguing natural wonders. See you next time.